All right, so welcome back from the slightly extended lunch break, and we're here in the final stretch of the second Castle workshop with two talks coming up. So the first talk is going to be given by several participants. So we have several speakers for this one, and if you would just give me a second. So we have several speakers for this next talk, which is going to come from two organizations. One is Gather.ai, and the other organization is Dinata, which some of you might be familiar with as they're quite a presence here in the UAE. And their talk is going to be on next generation air cargo through digitization, so with applications of vision-based inventory monitoring system. Okay, and we are just putting the final touches to make sure the speaker can come online. Great. So I will now introduce our speakers. So joining us virtually, we have Mr. Guillaume Crozier. And then here in person, we have Daniel Maturana, Sankalp Arora, and Praveen, right? Great. And then to introduce some titles, so Guillaume Crozier is the SVP Cargo UAE and Head of Global Cargo Strategy at Dinata. Daniel Maturana is the Chief ML Scientist at Gather AI. And Sankalp Arora is the CEO at Gather AI. So all to you.
Wonderful. Thank you so much for being patient with us. So we're going to talk about specifically air cargo and how Dinata with Gather AI is driving digitization in the space of air cargo, and why does it matter? So the structure of the talk is like we'll introduce what Dinata does, what are basic air cargo operations, the need for digitization for transparency and efficiency, and how we are driving that transparency and efficiency through a fleet of autonomous drones capturing images. We have a unique model in terms of a robotics company that we do not make our own hardware. So just sharing the challenges that come with not making your own hardware and the joy of not making your own hardware. But the most of the talk will focus on application of machine learning to this specific problem. And Daniel will lead that portion of the talk. So Guillaume, I don't know if you can hear us. If you can hear us, can you kick us off with introducing Dinata and air cargo to us? Oh, we can't hear you, Guillaume. Give us a second. Can someone help? Do you want to give it a try?
Can you hear me? 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 I'm hearing you very well. You can hear me as well? You're on mute now, guys, but I don't know if you can hear me.
Can, loud and clear.
You're on mute on Zoom. That's the beauty of new technology, right? Oh, now you're unmuted. Can you hear me?
Clear.
Oh, very nice. Okay. I'm so sorry. Apologize. It seems I'm making so much troubles actually in your conference. So apologize for that. And the slight delay is due to me as well because I was actually late from my previous meeting. I'm so sorry I cannot be with you all today. That would have been great to be with you face to face. It's always better. But I was still keen to pitch a few words on behalf of Denata and also for Gather AI, a fantastic partner that we are working with since a couple of years, actually. It's a fantastic, I would say, ideation story and MVP creation story and actually reaching the goals as we expected. Denata, I'm sure you know from an Abu Dhabi viewpoint because we are close neighbor and close friends and also healthy competitors. We are a ground handling agent. We have three divisions. One is airport operation, one is catering, one is Denata Travel. We are part of the Emirates group. And I am here representing the Denata Airport Operation Division, and more specifically the cargo and logistic product. We have refreshed our strategy moving forward because we have to acknowledge the fact that our cargo handling industry is quite old, right? And I'm sure as students, you know all the story of the Kodak and others company who get disrupted if they don't actually look forward and take the quantum leap as they have to. I think we are exactly in this space. We have to wake up and gear up because our traditional industry will not survive the new technology, which is just actually coming through. So we are an international company, not only head offices in Dubai, but we are not only in Dubai, we are in actually covering all continents. You have some fact and figures from the slide. We are handling more than 160 airlines on the cargo side. And yeah, we are reaching ish 3.1 million ton that was pre-COVID, and we are actually working hard to reach the same level again in terms of volume, but in terms of service we realized quickly that after the COVID situations that we all have in mind, all the big disruption that we now took the time to assess and analyze, COVID was a fantastic booster from I would say, innovation viewpoint. And that's exactly when actually we keep pushing further with Gather AI to develop new technology to actually deliver what our customer, which are airlines and also logistic stakeholder from the entire supply chain are looking for. And for us, you know, we receive a handling agent. You have to understand we receive actually all the cargo from a local community in one point, one given point, which are warehouses on airports, like you have in Abu Dhabi as well, and we have here in Dubai. And sometimes it's really difficult, you know, to cope with the volumes, and we have to manage a huge amount of throughputs. And we speak about air freight, so it means the decision is being made last minute. We have just few days actually to receive some booking and then to get ready actually to accept a shipment and to make it ready for carriage, as we call it, and then to load it on the plane. As part of the overall digitization strategy, we focus first and foremost on recording actually the right data. It sounds very basic for you at your level from an AI viewpoint, I'm sure, but I always repeat the same things. Before to reach, you know, I would say, artificial intelligence value point or tipping point, we have to get our basic right. And the first level is actually recording. The second level is computing. Then we start to automate, and then we can think about artificial intelligence and machine learning. With Gather AI, we've developed a very cool piece of technology that they will present. And we are reaching today actually a point where we are ready to launch it, right? And as a matter of fact, this is actually feeding our entire I mean, that help us to execute our strategy, and that's feeding our entire roadmap to actually start recording the right level of data real time, and then start thinking about intralogistic automation and also ULD optimization. So I try not to say too much because the full presentation will explain into details what is it, right? I just want to say that while we come from a very kind of old and traditional industry, air cargo industry, I think there is big motion for us to innovate and actually get ready for the next leap, as I said. The Amazon of this world and the Kenya of this world are definitely a very good benchmark. I've been in Seattle recently, and I was actually listening someone from Kenya or yesterday who came in Dubai during the ground handling conference. What they do is just amazing, and the scale of it is just insane. We have to get ready because I know you are Abu Dhabi, we are Dubai, but UAE, let's put it that way, must remain the best logistic hub of the world. And I think we have more to do together, joining forces. but we need to keep innovating and making sure we bring the value proposition to the market and also create the cost effectiveness we have to. So because I prefer doing than actually talking about it, that's why we are where we are. And you have with us on the stage a fantastic entrepreneur with Sankalp, of course, and his colleague. And also you have one of my colleagues, Praveen, who is here today and actually is really doing the job, on the field and making it actually fit for purpose and working with our tracing department, working with all the ops departments. And I think it is also a very important angle. We speak about change management, we speak about how we make it happen. I think with Praveen, you have in person someone who can really explain our challenges and also our success. And also how motivating and inspiring all of this is. I think Praveen a day came to my office and said, you know what, boss, I was never thinking in my job that I will ever actually implement drones in the warehouse. Now this is happening. This is so cool. And I think I will just finish here. Thank you so much for having me. I wish you a very successful session. I'm more than pleased to have more interaction moving forward with the university, a bit because Abu Dhabi and Dubai, we have a lot to do together. Thank you very much.
Do you want to talk us through the needs of digitization?
Yeah. Hi. Good afternoon, all. As Guillaume said, the need for digitalization is over the cargo industry has been evolving, and it's at every touch point as a customer. They would like to have an update or a track of their shipment traceability, and that's a few of the initiatives that we have initiated at our end. Is state-of-the-art handheld devices, so we record every transaction right from the aircraft offloading right till the customer doorstep. And another one which we introduced was the appointment and dock management, which is a just-in-time service for our customers. So we know who the customers we are serving, what time do they want to come and collect their cargo. So they can do a booking, we are prepared, keep your cargo ready, you come and pick it up and go. Rather than you having to come to our docks, have a wait time, and then that leads to irate customer. Sorry, yeah. And having that, the need was, in our warehouse, we had this inventory checks that was being done. Every day, somebody used to go around and manually do that. That's when Gather partnered with us. And I think Sankalp will take you through the rest of it.
Thanks, Praveen. So mostly talking about the need for visibility, because at an air cargo customer is essentially paying for speed, because you're sending your cargo through airplanes because you want to get it done faster. And one of the aspects of that speed is you want to see how your cargo is moving through the facility. And this is what Gather AI and Dynata partnered towards, which is how do we use or how do we make warehouses transparent for customers and provide them visibility in warehouses. So the way we are doing it is actually automating inventory monitoring in warehouses using a fleet of autonomous drones. So just a quick video of what it looks like. It looks like this in concept, actually, where a drone flies around, scans these boxes, scans barcodes on them, scans the texts on them, and then keeps doing its job of slowly going through the inventory and recording. I say slowly, but this has been able to reduce inventory monitoring times for a facility from 48 hours to just 4 hours. So clearly there is no GPS in facilities. So we use these Aruco tags to map the facility. And once the images are collected, then we produce data like barcodes, box reads, temperature monitoring, volumetric measurement, and all of that at a press of a button. And basically, I think when earlier in the day I introduced Gather AI, it's about gathering physical data and making it searchable. And that's what we are doing in our warehouses, in Dynata's warehouses today, where a person sitting anywhere in the world can actually look through the warehouse and figure out how their cargo is moving. A little bit of where we come from. This is the world's first full-scale, fully autonomous helicopter, a big part of Daniel's PhD thesis and mine. And it was this helicopter that was operating that I was talking about this morning that gave us the idea of making drones curious. And then we miniaturized that tech to backpack carryable drones for US Department of Defense to actually find and locate moving assets in an environment. My drones used to be curious about moving assets, about landing zones, about wires, and now they're curious about boxes and barcodes. So generally, if you see any robotics company that has formed in the past, it has relied on heavy investment in building their own hardware. That's because commercial grade robotics hardware wasn't just available. So even Kiva Robotic Systems, this is from a photo taken from IEEE Spectrum, one of the most successful logistics automation, where these little robots drive around in the warehouse carrying these carts on them. So if anyone at Amazon wants to pick a little item, they don't go to the item comes to the picker by moving these shelves. Boston Dynamics is a newer example in similar vein, where they are picking robots, but with massive hardware investments. And that is a model that doesn't scale at low capital investment levels. And it takes a lot of time to actually build the hardware and then validate it works like it's supposed to work, increasing the risk. The way we are different at Gather is we just use commercially available off-the-shelf hardware. And we like to compare it with when Google came up as a search engine. It was almost the first company that didn't build their own server farms. There's like, commercial off-the-shelf server farms, and started taking that hardware and make. So it's almost the Google moment in the robotics industry. So we provide a robotics solution without making robots and minimizing the need for upfront capital, both for us and for our customers. It all sounds great. Like if you can use an off-the-shelf robot, why not? But there are some attached challenges to it. So if any one of you wants to get inspired in doing the same or joining us, I just wanted to share a couple of challenges that come with having off-the-shelf robots work for you. One is you're not as close to the hardware anymore. Like these are robots that you can buy out of Amazon. You don't get any time synchronization with the hardware. And the camera you get is not a machine vision camera. It's a rolling shutter camera, almost like the ones you have in your cell phones. Slightly worse, actually. So the challenges that end up with that, just to give you an idea of what rolling shutter does. So a global shutter camera is a camera that in which all the pixels get activated in the same time, and you get a full image. But the camera in your cell phones, and your laptops, and commercially that are available, a scan line goes through the pixels very quickly to register the image. The effect of that scan line is a fast spinning propeller actually looks like a curved object. So why does this matter? It matters if you're trying to match images and features in the environment and use them as geometric cues to localize your drone. So one has to deal with rolling shutter effects if one has to use the benefits of using commercial off-the-shelf hardware. The other challenge that plays in itself is that there is no time synchronization between sensors. So if the IMU of the robot is telling me that I'm accelerating at T1, whereas the camera is telling me, oh, the speed is not changing, you're not accelerating. So like which information do I trust as an algorithm? So the general way of solving this in robotics community is make your own hardware, have everything time synchronized, use machine vision cameras, and it's solved. The difference is this drone costs $2,500, or custom hardware will cost you around $50,000. So how do we solve that challenge? I will leave it, since the main focus of this talk is actually machine learning. I'll give a very high-level idea of how we solve this challenge. We make the robot curious about its own state. So it tries to do actions to minimize its uncertainty about its own state. So for example, if it gets lost, it will turn around and look at where is the closest feature to me that I can match to, and how I can go slower so that I don't have rolling shutter effects in my environment. Just quickly how it looks like. And a lot of this work of being curious on its own state is inspired my PhD thesis at CMU, if you're interested in that. But this is the view of the camera itself that is on the drone. It is moving from pallet to pallet, making sure it's localized, and then taking images of the pallet and going. So you see how the camera motion is jumpy? It's jumpy because the camera is actively looking at how to localize itself instead of just being static. But this is a little bit of fun in terms of the challenges of autonomy and how we address them. But now on to the core of the talk, which is the machine learning challenges that come with off-the-shelf hardware.
Okay, it worked. Thank you. Hello. Okay, so the autonomy team has done a great job of getting the drone to capture data. So what we get are images, just a bunch of images. What we want to do is turn these images into insights for the customer. What do they want to know is where is what, where is their stuff? And this can be hard, you know. There's many reasons. This is one situation I saw reviewing some data last week. And if you don't read Spanish, it says, hey, Joe, if you move a pallet, please put it back from where you got it. This is the last time I'll tell you. So it's really easy, you know, for people to misplace things. Not in Denata, though. Their operations are top-notch. But some of our other warehouses are a little bit messier. And we want to, you know, use a drone to help people find the pallet that Joe misplaced. It's not the actual name, of course. At any given time, the drone knows where it is, thanks to the work of autonomy, and it knows when it takes an image, where in the warehouse it's looking. So that is the where. We want to know the what in what we are looking in the image. So what kind of things do customers want to see in their images or get from their images? For example, codes to identify inventory items. We can get them from barcodes, OCR. They want to know how many cases or boxes they see. And also how these cases are arranged in something called stacks, in their stacks, which is a pile of boxes, which have a type of arrangement called tie-high, and I'll talk a little bit more about later. And sometimes they also want to know whether there's anything at all, you know, if the rack location they're looking at is empty or not, because if it's empty, you can put stuff in there. Now this, easy, right? Maybe that's what I thought. For example, hey, let's read barcodes. How hard can it be? You do it in the supermarkets all the time. Your phone has a barcode scanner. But in these situations, you're pointing your camera at the barcode. They're not designed to read barcodes that are captured maybe like 2 meters away from a drone. So in practice, our barcodes look like this. You know, Nyquist theorem, the theory textbook says you need 1-2 pixels per bar to read a barcode. We often have to operate at sub-pixel resolution. We have multiple bars per pixel. And on top of that, we need to deal with glare, crossed out or damaged barcodes, deformed barcodes. So, okay, that was not that easy to do. When we fixed our pipeline, one thing that happened is we were reading too many barcodes. Like customers were saying, hey, you know, you're reading a dozen barcodes in this image. We only care about this one barcode that identifies our inventory. We were reading barcodes from the background, barcodes from neighboring locations, from the sides of boxes. So to reject these barcodes, we actually also need to understand the image a little bit better and say, hey, that's in the back, this is in the side. Don't read those. Then also counting boxes. You know, not all boxes are those little nice brown boxes you see every day. There are also lots of colored boxes, all sorts of shapes and colors, and squeezed tight together so you can't really tell them apart, wrapped together. So that also makes it difficult to even just count individual boxes. And when we want to infer like how these boxes are arranged in a grid layout, this so-called stack norm, then it's also kind of visually ambiguous often, and I'll talk about it later. Then occupancy, not that easy either. You could say, hey, let's just count the boxes. If there are no boxes, it's empty, right? No. You know, in the top example, for example, you can see there in the back something that kind of looks like a box, but it's in the background, so it doesn't count. This location is empty. In the bottom, there legitimately is nothing that looks like a box, but it's actually not empty because it has all those pallets in there. In our approach, our general principle is, you know, we got to keep it as simple as possible, not any simpler than that. I'm not sure who said it, but I agree. And one big difference from academia, which is both of our backgrounds, it doesn't matter if it's novel as long as it works. Sometimes we do novel things anyway, but that's not the point. That's not what customers care about. So we engineer a modular pipeline to deal with all of these tasks that I outlined here. And in general, like the principles we use here, again, one of those simplicity. When we start, we might say, hey, maybe we don't use ML at all, which is silly, right? Like I did my PhD in deep learning, we were in the learning workshop, but I think you really gotta try it first. Just look at the data, look at the pixels, try some heuristic or hack, as we used to call them in grad school, and really get familiar with the data, what the problem, what is the structure of the problem that you can use to make it easier. Often, of course, you outgrow those heuristics, those hacks, once you get into a lot of special cases. Then, okay, ML. You don't need necessarily, at first, deep learning, right? You can use other old school ML. You can use random forest decision trees. We tried that. Then you can often outgrow those as well, and that's where we are in a lot of cases. We look at all the archive papers. We look at the state of the art, maybe last year's state of the art, and use that if we can. And if not, then we really go beyond the state of the art, which is, of course, the most fun and exciting part, but not something that we do all the time. We do it sparingly because, of course, it's uncertain and we needed to deliver features yesterday. And we can't necessarily afford, 6 months of research. But when we have, I think, achieved some pretty fun stuff. Now, I think that was, there we go. This is a big outline of the pipeline that we have. It's simplified, it already looks kind of complicated. But each of these are one of the tasks that we solve in order to all integrate it together into the kind of insights that customers want. And I'll outline in the next few slides some of the things that we do here at a high level. So for example, reading barcodes and labels. I think a fairly direct approach. First, detect things with bounding box. Then we rectify these labels. That means we turn something that is a trapezoid in an image into a rectangle. Then we apply enhancement, kind of a secret sauce. And you can think of that as like, Blade Runner or CSI when they do zoom, enhance, and they convert like a really pixelated, blurry image into something nice and clean. That's what we do. And then we do barcode reading, then we do OCR. Here, in this example, go from here to here. And this lets us read some really cool cases that are, I'm often pretty surprised. We read, things that are crossed out, ripped, really small. I talked about subpixel resolution, glare, these other small blurry barcodes, sometimes the ones that are deformed. So I'm pretty proud of that. Now, okay, boxes, anti-high. And here's another funny case I saw. Do not double stack. A stack is a pile of boxes. And, people, they're not, often you have stack norms. You want to arrange things in a certain way. Sometimes these things are not respected. Again, this is not the and this is usually described as something called tie-high. So this is essentially here, 1 layer, 3 boxes, and 2 layers, which means the high is 2. Tie is 4 because you can see 4 boxes here. High is 2. Sometimes the stacks are not complete. Some things are picked off the top, but you still say tie high 3 and 3 in that case. The pipeline here is we first detect boxes individually, same as before with barcodes, but then we group them together with a segmentation approach to say, okay, these all belong to a single stack. We also use monocular depth prediction to say these are the stacks that are in the foreground that we are interested in. And finally, for each stack that we are interested in, we apply some kind of like a clustering algorithm to infer what this tie and high is. And works even in challenging cases. Here's 4 by 4. You can see these boxes are not a perfect grid. Still get the right answer. Some other cool results over there on the left. And remember how I said, hey, sometimes we read too much? Well, actually, we can use the results of the previous slide to filter out things that we don't care about. If there's a barcode that is in a stack that's in the foreground, then we say this is a candidate to actually go into the WMS. If not, we will reject it. And some examples, barcodes that they're in the back, we filter them out, they're in the back on the slide. And it's maybe not as easy as it seems sometimes because you see that orange rectangle is what the drone knows about where a location is. But just because of perspective effects, often things still fall in this region of interest. So we have to use this machine learning to reject those cases. An occupancy empty, this one is simple. I don't have too much of pretty diagrams here, but it's really just a binary classification problem. We say, hey, we look at an image. This is occupied, not occupied. The twist is we have an additional layer of attention that we apply to each region, so we can focus on, say, hey, look here on the left and predict whether it's empty or not. You could say, why don't you just crop it out and predict that? Well, we need the context. So this is another cool pipeline here. These are two examples from the intro that we got actually right. And this is actually one of the best performing pipelines, despite being one of the simplest. And it's interesting, too, because it's one example where data really helps. Just having tons of data and retraining all the time. Much better than fancy pipeline. Now, as you might imagine, there's challenges in implementing this out there. We started out in mobile, so we had to keep everything super lean and mean. Then we moved to the cloud, where we still want to keep things, under a minute per image, ideally. So again, we kept it simple. We monolithic architecture, putting all on a single machine. You might think, oh, wow, can that actually handle all the traffic? Yes, you'd be surprised, especially as you saw, we are used to putting algorithms on tiny drones. So compared to that, a beefy GPU machine on the cloud is, almost limitless in terms of power. This eventually will run into limits, of course. Vertical scaling, so just making a bit bigger and bigger machine eventually will run into some kind of limit. There's just no bigger machines. It's not cost effective to use just like one big machine all the time. You want to be able to scale, turn on and off our nodes. Some nodes don't need GPU, so maybe we can run them on CPU computers. And we want more flexibility and redundancy in terms of our deployments. So, and also we need to decouple some of this scheduling and data flow logic that we have mixed up in there in our big monolith. So we want to break it up. We want to open it up. Here's another example. This is the item as a case. Do not cut open and split up. It does happen because there are warehouses where people open the cases and redistribute them. Again, not the nada. So we want to open up into a more distributed architecture so that we can scale up easier. We've been looking at various solutions in the space, and we're happy to say we've been beta testing Petum's product. It's actually really cool. Here's a diagram that Arik himself drew for us, and actually maps really well to how our pipeline would look. Each of these nodes is basically a step in our architecture. It can be containerized, which really simplifies and cleans up a lot of the way we package our code and deal with the communications between the nodes. It has, a lot of the power of Kubernetes under the hood, and it lets us use it at the same time. It's a little bit easier to use than just raw Kubernetes because it has this graph abstraction that maps really well into how we deal with our ML problems. So we're really excited about it, and we really plan to try like a full prototype hopefully this year. So yeah, now outlook. I guess conclusions here more on the ML side. So one is like, problems that look simple at first glance that get complicated once you get into the real world and you need something that's not just a demo and not something like that goes from 10% accuracy to 60% accuracy. You need something goes from, 93 to 95% accuracy. And to build this kind of product that is like this big but specialized, I still think the best way is like pragmatically engineer like a pipeline that is modular. There's still no like one magic wand, that transformer warehouse that's going to magically say, oh, these barcodes are here, here, or there. if it does come up in a few years, I'll gladly use it. Less work for me. And finally, as I said, we've been keeping things pragmatic and simple, but we are definitely constantly striving for more solutions, more features, better performance. That means going more into research territory, more sophisticated models. If this is the kind of thing that interests you or anyone listening, please get in touch with us. We've been successful so far and are hiring. And now zooming out into what the broader impact of this, whole system is. It's just not the vision, it's the whole drone, the autonomy. I'll let Praveen take us home.
Thank you. So basically talking on the impact, what we initially used to do before Gather came into the picture was we had a team member go down, print down a WMS file, check each and every rack locations manually using a man lift or probably a forklift to take out the cargo, go around and verify each and everything. Because warehouse inventory is part of any air cargo industry when you have a warehouse. After that, he used to come back to the office, re-verify it along with the system. Now with Gather in the picture and using drones, the staff on a single click can navigate the whole warehouse through the digitalized image of the warehouse, which is already on the Gather, and it gives us the end results of just only the things that we need to verify. So there, my staff does not have to spend more time looking for what's across the whole warehouse. And moreover, we have all the images digitally stored, even for future, as well as historic references. This saved manpower, this saved a lot of safety risks was not there, and as well as less time consuming from our side. So thank you, Sankar.
All right, so it is now question and answer time. Anybody from the audience would like to ask our speakers? Oh, you have a question?
So my question is to Daniel regarding the barcodes scanning, and I think that is the part where I have two questions related to that, just curious. The first question is, one thing I noticed is almost all the images scanned by the drones are very low lit. Yeah, so why? And does image enhancement and restoration, like burst image enhancement or restoration techniques, would that be helpful? Do you already use them? That's my first question.
Yeah, no, that's a great question. So we try to actually brighten them up a little bit in the slides. Sometimes we don't do it completely. The main reason is that it's actually kind of, whenever you increase in a camera the sensitivity to light, you're increasing the noise. So that makes it harder to read barcodes. And on the other hand, if the image is darker, the neural net actually still works really well because they're almost invariant to lighting conditions. They're just looking at differences between pixels, not so much the absolute values of the pixels themselves. So they actually don't care. You can operate in almost complete darkness and the neural net reads them, which of course is a problem because sometimes our customers are saying, hey, all the images are super dark, I can't see anything. So we have to brighten them after the fact so customers can actually see something. But that's the main reason. And as to your other question, yeah, some kind of burst photography, like stacking of images, that would be amazing. But one of the challenges is, as we are using off-the-shelf drones, so we don't have complete control over we capture images, and we also have constraints in terms of how much time we could take to capture each image. Which means that we have to often just deal with lower quality image. And in fact, I think that's one of the main issues that a lot of our competitors have faced. All in all, the cameras we use are actually really good in terms of resolution, especially for the cost. But even then, we are often on the verge of being able to read anything at all. So if you have any camera that's a little bit worse, it's going to be harder. But yeah, I think, going into the future, I look forward to maybe more megapixels, better hardware, where we can actually get more out of each image. But we have to use what we can get right now.
One more question that I have is, you already spoke about how it reads a lot of other things, maybe like reads a lot of other barcodes. So I'm just curious, there would be some other text that would be on the boxes, right? So is it because of how your work, like flowchart works, that you don't have, you don't confuse with the other text?
No, it's actually a big problem. Sometimes we read a lot of stuff that we don't care about, barcodes and text. And we deal with it in various ways. One of them is a more fancy version where we try to filter out background things. There's also a simpler version. Again, try to keep it simple. Often customers say, well, we know that the barcodes we care about are 3 digits, followed by 2 letters, followed by 5 digits. So that's one really easy filter to apply. Like, if anything does not fit that mold, we can filter it out. I think it's a little bit trickier than that because we have to deal with mistranscriptions sometimes. So there's a little kind of wiggle room between just doing the really simplest thing, like filter out anything that does not meet the template, to try to being a bit smarter and able to account for, 1 digit that was mistranscribed, like instead of a 7, you saw an 8, 8 or 9. And that is the one area I think where something, all these large language models maybe could actually be helpful, where we can say, here's a bunch of examples, just figure out if this is a good example or not. But right now that we're not using that kind of techniques yet, but we are monitoring the space to see. But no, you're right, it's tricky.
All right, so a question from me, right? So, putting together what you've done, right? There's a clear message of sustainability, especially in the capital sustainability, where you talk about let's not build expensive robots that only a few people can afford. Let's use off-the-shelf parts, and let's find a solution that works with the cheapest possible hardware you could possibly imagine while still not having an accident, right? And I want to know what you guys think about the future of, let's say, sustainability in robotics, right? As clearly you've got something going on here. Where do you see the next opportunities for your business, right? Right now you are in the cargo logistics space, and I am just curious, again, as from the MBZI perspective, we have COP28 later this year, right? And then we start thinking about how we in the UAE can impact areas that are in all walks of life. So love to hear if you have any thoughts to share on that to our audience.
Oh, that's a really good question, and something that we have thought deeply about, right? Is starting Gather AI, starting a company, you're dedicating essentially at least a decade of your life in making something successful. So what we are doing with drones is essentially within the warehouse, enabling operators like Praveen and his team gather the data of their warehouse at a press of a button. So then you don't have to use forklifts to go around the warehouse and gather it. So it's sustainability not just at our level, but sustainability and energy savings at the operator level. But gathering data doesn't have to stop at warehouses. At the same concept of collecting data at a press of a button, the immediate ancillary next step is you go out to yards where all the trucks are passed. Today, how people take inventory of yards is actually people driving around in trucks and say, oh, that yard location is empty, that one is full. You don't need to do that. You can send a tiny drone and figure it out, if specifically armed with the right data gathering engine. So that's data gathering at a press of a button in yard, which is ancillary to supply chain. If we take one step bigger than that, and if you humor me for the vision, the data gathering can be as simple as someday you need to inspect the roof of your house. And you pull up an app and say, inspect my roof. You don't care when, you don't care how, but a drone sitting in a pod comes, inspects your roof. While going back, inspects the road and maybe the overhead electric wire. Goes back to its pods and digitizes and monetizes all 3 data streams. All of that is data gathering at a press of a button, but driving sustainability where people and heavy vehicles don't have to be used for inspection anymore.
Right, and it's saying that part of the sustainability story is also making sure it's safe, because I think we all agree, right? In the less developed parts of the world, right, safety sometimes, unfortunately, takes a bit of a backseat, right? Compared to highly regulated industries in developed countries, you may not have a workers' union in some countries, right? And I think this is a very encouraging message that we can think about sustainability also from the perspective of fewer injuries, safer working conditions for people. Great. Now, one last check. Are there any other questions or any questions from the people that are online? Okay. All right. With that, let's thank our speakers once more.
Thanks so much.
All right, and we are now down to the very last, but not definitely by no means the least, talk of the session. And I'm pleased to introduce Yamin Shi from the Beijing Academy of Artificial Intelligence, and he's the head of the Z Lab. So that's just a bit of a mysterious sounding name. So hopefully you can explain a little bit more what your lab does. Great. And before I forget, his talk is going to be a glimpse of large model and AGI, artificial general intelligence, from the perspective of applications. So as soon as he is set up, he'll begin.
Are we doing that?
We can try it out. It's very Let me check the names of the key visitors. Can you use this the presentation?
Yeah.
Let me check it. I'm going to say.
Okay, thank you. I'm Yimin from Beijing Academy of Artificial Intelligence, which can be abbreviated as BAI. And as just described by Qirong, I'm the head of the lab. What is this the lab? At first, we don't know what we are trying to build. We thought we are something between research and the application. So what it is? We don't know. So we thought it's something like X, but X lab is taken. So we chose another character, this Z. So our name is Z lab, and. It is a great honor to be here today and present to all of you. Previously, I have named a title which contains the word AGI, but I finally decided to remove it just because I don't feel we have a definition for AGI. Some of say AGI is that it can do whatever a person can do, and it's so much powerful. But in my opinion, human is not that powerful. For example, most people don't know maybe a lot of things, and we just do what we are good at. So that means we are trying to build a much powerful machine which is powerful than human. So which is too big to talk in this talk, so I just have to remove it. Hence, I renamed my title to A Glimpse of Large Model and AGC by BAI, and I will talk about the large models and AGC models developed by BAI and some of my thinkings about these models. In this talk, I will briefly review the history of large models, and then I will talk about the models developed by BAI. My final section is to talk something about the maybe the application or the future of large models. In the area of deep learning, a revolution of unification is led by the development of large model. Compared to the millions of, or maybe billions of parameters before, current large models tend to have hundreds of billions of parameters, which is way large to comparing to the model before. For example, GPT-3 has 175 billion parameters, and Google's PaLM has 540 billion parameters. The development of large models has attracted many attentions from over the world. In China, there are many organizations which are trying to build their large models. Of course, BIS is included, and we have done some works. If we plot all the large models, we can, on the chronological timeline, we can see that after 2022, there are much more large models developed recently. Basically, we can summarize the development of large models into 4 aspects. The first one is more parameters. The parameters of large model has increased from a million scale to billion scale to hundreds of billions of scales, which are too large. And our, the second is more data. Large models are being trained on massive of data, and our UDA 2.0 was trained on 4.9 terabytes of data, which is a very large data set. And considering the petabytes of data collected every year in so many companies, we can expect that there will be much larger models being trained and using more data. During this process, the privacy violation problem should also be considered, which has not been discussed for many times. And third, I believe there will be more modalities. There are more and more researchers believe that by including more modalities, we are able to achieve a better AI or maybe AGI. I don't know. And by using more modalities, we can give the model the ability of maybe a better of sensorability and making maybe a good decision. At the same time, multi-modality approaches also offer a possibility that maybe we can create something, maybe some new user interaction or maybe user interface. The last one is more computational power. It is not possible to train a large model without super computational power. Normally, we need thousands of A100 GPUs to train a GPT-3 level model, which will cost millions of dollars to just rent the servers. And there is thing that the OpenAI trains their model on more than 20,000 of A100 GPUs. In this talk, sorry, what is this? LLM, or large language model, is the first wave of large model and became a much hotter topic recently because of ChatGPT, which was developed by OpenAI. What attracting the researchers is that the large models have the ability to emergent new abilities, which means it has the ability to generate novel and meaningful content by drawing from vast amounts of pre-existing information. For example, GPT-3 promised in-context learning, in which the language model can be adapted to downstream tasks simply by providing it with a simple prompt. This is an emergent property that was neither specifically trained or trained on purpose. Here I borrow an animation made by Google Research. When the parameter reach the maybe say 62 billion and more parameters such as hundreds of billions of parameters, it will get more abilities. Except for GPT-3 and ChatGPT, there are also some other large models that have been well known, such as the POM, which is developed by Demand, and POM is developed by Google, and Gopher is developed by Demand, and also Galactica and OPT developed by Facebook, which is also known as Meta, and GLM from Tsinghua University, and Bloom from Big Sense. Not only language, there have been some work trying to train models on multimodalities. For example, in computer vision, Google has proposed its VIT 22 billion, which means it has the 22 billion parameters of CV model. And researchers in BAI have also tried some large models for computer vision, such as EVE and Painter, which is an encoder and decoder model for computer vision tasks. And Microsoft proposed its VLE, which is for speech synthesis, and Google proposed AlphaFold for protein structure prediction. As the development of large model, we should be able to see some more modality-oriented models which will be developed. For example, there maybe will be large models for varied data. For example, medical, weather, astronomy, and so on. An exciting application of large model is AIGC, which is to generate content by AI. The most successful one of AIGC is the text-to-image. For instance, DALL-E, DALL-E2, and Cogwheel developed by BAI, and Still Diffusion, and also Outfusion developed by BAI. In most of these methods, there will be a text encoder model, such as in DALL-E2, GPT-3 is used as the text encoder and to understand user prompts, and in Stable Diffusion, Clip is employed to understand text and image content. Here, Clip is a multimodality pre-trained model. Some other applications has also been studied and will play an important role in the future of AIGC. For example, Imaging Video, which is developed by Google for text-to-video, and Dream Fusion for text-to-3D, and the Music LM, which is text-to-music, is pretty interesting. They recently proposed with ControlNet, have been drawing a lot of attention, and it can improve the quality, image quality generated by Stable Diffusion. Long before ChatGPT, BAI has paid a lot of attention on the research of large model and proposed UDA 1.0 and 2.0. In the past year, we have also done more work on the development of large model and contribute to the open source community constantly. As said by Professor Dr. Ismail, who is the president of the Arab Academy for Science, Technology, and Maritime Transport at the BAI Conference 2022. Building large Arabic data sets and models has a significant impact on science and technology in the Arab world. Inspired by these works, in cooperation with institutes of Arabic-speaking countries, such as AASTMT, BA, and IAI, we released 2 Arabic data sets. The first one is Arabic text, which is the largest open source pre-training Arabic dataset, and is strictly cleaned and high quality. The second one is Arabic text NTG. It's a large-scale multi-topic Arabic news title generation dataset. During this process, we collect, aggregate, and clean from multiple publicly available Arabic web data. And we, after this process, we get the Arabic text, which is 201.9 gigabytes. The final, we also provide baseline results and evaluation scripts and code for these two datasets. Based on Arabic datasets, we further released the so-called large model, but maybe we can use this as the baseline model, which is ALM 1.0. It's a pre-trained language model based on auto regression and blank infilling. It achieves the third place on the LUE leaderboard, the second place around the open source community. And it is also a large model for both understanding and generation. Maybe it's smaller than yesterday the large model. And if you are interested, you can access the code and the model from GitHub. We have open source the model and data as part of Flag AI toolkit. In BAI, we have a very brilliant computer vision team who's targeted to develop a vision foundation model that's general, scalable, and also a few short learner for a wide range of vision tasks. We hope one day you can use a vision model similar to GPT-3, which is much powerful than current pre-trained model because of its emergent abilities. The difficulties of designing a general and scalable vision model is that the vision tasks vary significantly, not only on their own output basis, such as depth, masks, labels, and captions, and so on, but also the information they need. For example, how do we construct informative and proper prompt for vision task, which is still unknown. Here we divide the big goal into two tasks. First, we need an image encoder to learn strong and universal representations from large-scale images. In addition, we need an universal vision decoder to solve varied vision perception tasks such as image segmentation, key point detection, and depth estimation. For the pre-training part, we start with the question that what makes a good representation for vision? We go through different kinds of vision tasks and find that the most important information they need is either high-level semantic or low-level geometry. So we combine the best of both worlds, which is clip and masked image modeling, where clip is for semantic feature extraction and masked image modeling is for structure feature extraction. Our simple yet effective pre-training approach allows us to easily scale up the model to 1 billion parameters. This leads to our EVA, which is the best pre-trained model at billion scale for computer vision. EVA achieves the state-of-the-art compute results on a broad range of downstream tasks and significantly pushes the development of some very challenging problems, such as long-tail object recognition and segmentation. In addition, EVA as a strong pre-trained image encoder can further help clip to connect vision and language. With pre-trained EVA, we can easily train a multimodal clip with 1 billion parameters and achieve better zero-shot results with fewer image text pairs. In addition to the strong pre-training, we also proposed a generalized model termed Painter to solve varied vision tasks with single model, which is the decoder for computer vision. The most challenging problem of creating a generalist vision model is that vision tasks vary significantly in output representations, such as segmentation, detection, and post-estimation. Several recent methods will follow the solution in NLP and convert visual perception problems into NLP problems by discretizing the continuous output space of vision tasks. However, we believe that images speak in images. That is, image itself is a natural interface for general purpose visual perception. To achieve this, we redefine the output space of vision tasks as images and unify varied vision tasks into an image imprinting problem. During the training of a printer, it learns to define the task by input image pairs. For example, the left column, the two pairs of images are used as the input to the model, and we mask some of the patches and predict them according to their neighbors. So in this way, the model can learn the task definition. And in the inference stage, the model uses one or more proposed pair of the images as task prompts and predict on the new sample. Our generalist printer achieves strong performance compared to well-established task-specific models on 7 representative vision tasks, ranging from high-level vision understanding to low-level image processing. In addition, printer significantly outperforms recent generalist models such as Pixel 2 Sequence V2 and UVim. Most importantly, for the first time, printer demonstrates visual in context learning successfully. Printer automatically perform vision tasks according to the input prompts, even the tasks do not exist in the training data. For example, there is no training data for cell segmentation, and the key point of a chair, but printer can perform the task given the corresponding input prompts, which is the last 2 rows. Not only single modality learning, we also have a team on multi-modality learning. Before going to our art clip, I have to briefly introduce CLIP. CLIP is short for Constructive Language Image Pre-training, which is trained on a variety of image text pairs. And it has been used as the text or image encoder of many text-to-image models. Based on CLIP, we proposed bilingual outclip and multilingual outclip AMNI. With the help of CLIP, natural language is used to reference learned visual concepts and enabling their short transfer of the model to downstream tasks. Then we can perform text-image retrieval and image classification without any labeling. The training of outclip including 2 stages. In the first stage, the machine-translated English and other language pairs are used to train a multilingual model. In this way, we can align a more powerful pre-trained model to CLIP text encoder. In the second stage, we conduct contrastive learning on multilingual text-image pairs, which is similar to CLIP. Finally, we can get a multilingual CLIP termed outclip. The advantage is that we can use less multilingual text-image pairs, and we can also get a multilingual model which currently supports 9 languages, and which include Chinese and Arabic. Outclip is able to achieve comparable performance to original CLIP on English tasks, and it is also a good replacement of CLIP to get multilingual ability in many scenarios, such as we can replace clip in Stable Diffusion to get a multilingual text-to-image model. And our outclip M9 supports 9 languages, which include English, of course, but we also support such as Chinese and Arabic. Stable Diffusion is a very popular and open source text-to-image model. We have to thank the authors for their great contribution to the open source community. Based on Stable Diffusion, we want to develop a text-to-image model that supports more languages other than English, including Chinese and Arabic. Though there are a lot of text-image pairs in English word, the pair data in other languages is very limited. A working around for this problem is to replace clip with outclip, which has been pre-trained to align the embedding representations of text and images. And then much less text-image pairs are required to fine-tune the Stable Diffusion pipeline. The key idea behind this approach is that multilingual text-to-image model equals to English text-to-image model plus a multilingual alignment. By comparing to Stable Diffusion, we found that Stable Diffusion can generate high-quality images close to Stable Diffusion on both English and Chinese prompts. If you are interested, you can also try Arabic. Well, I cannot read Arabic, I cannot write it. We also found that Diffusion is better at understanding Chinese concepts, which may be because we use more Chinese trained data, and for example, our Diffusion is able to generate better ink painting images and Chinese traditional building images, which is on the red column. During the experiment, we found that for the same prompt translated, our model generates different cultural styles to some extent. This means by training on corresponding language image pairs, models have the ability to map language and culture. Our models and code are open source and available in Hugging Face diffusers library. If you are interested, you can also try it on diffusers on Hugging Face base. We not only released the model, we further developed a platform named Flex Studio. The domain name is flexstudio.bai.ac.cn. In Flex Studio, we integrate the multilingual ability of Diffusion and provide free access to all people so that the non-developers can use Diffusion without having to learn programming. We also provide many predefined or pre-trained styles to lower the threshold for writing prompts. Besides web-based Flex Studio, we also provide a WeChat mini program version. You can scan the QR code if you have WeChat installed. In Flex Studio, we also support the local modification of an image. For example, in this video, we want to replace apples with pears. All we need to do is mask the apples and change the prompt to a basket of pears, and then submit the task. Wait for seconds. We got an image of a basket of pears. After so much effort and these projects, the ultimate goal is to apply these outcomes to the real world. There have been many attempts in the area of generative AI application. Among them, quite a number of companies used or related to GP3, which is backed by OpenAI or Stable Diffusion. Some of them have been widely used or being very famous, such as Jasper, which is a text generation company, Runway, a video generation editing company, and Midjourney, which is a text-to-image company. Copilot with a code generation product. Most of these companies and the products will use a single modality. Maybe in the future, we will need more modalities, maybe some kind of multi-modality model. For example, we can use large language models and large computer vision models to build much powerful AI-GD products and models that can read both images and languages. Hence, we can get a much powerful chatbot or assistant. Or we can merge large language model with robots so that robots can understand commands and perform the actions. And we also can merge large language models with tools to do some more complex tasks. But what if we want something more powerful, for example, AGI or robot assistant? How many modalities do we need? To understand and output language, we need at least a large language model. Instead of just print the sentence, we also need it to speak and tell us. So we need a large text-to-speech model. In order to get professional knowledge, a standalone knowledge base is required, and it's better if it can access the internet and maybe request such as search engine. Then a large vision model is also important as the part of AI to understand the physical world. And vision model is also important for action and human interaction. After we understand the commands, then we also need a large action model to perform these actions. Finally, I believe by integrating NERF into the model will help model extract spatial information and understand the physical relationship between the objects. At last, we can abstract the above procedure into a formula where future large model equals to large language model plus text-to-speech model, and it needs a knowledge base, and it needs the power of computer vision, and it uses the action model, and finally it requires the power of NERF. Okay, so that's all for my talk. Here I summarize all mentioned projects in this talk, and all the model and the code are open source on BAI and GitHub and Hugging Face. If you are interested, you can try these projects. Okay, that's all. Thank you.
All right, so any questions from any of our audience members? Or maybe I can begin with a question, right? So clearly your talk is really selling the message that the future of some of these large generative models lies in combining as many modalities of information as possible. And of course, you've demonstrated some examples in your lab's work. Now, I am curious about a number of aspects. First one being that, as we if we think about how modalities are currently incorporated in models with like two modalities, right? For example, stable diffusion is a case of there being you embed basically the text into a attention layer that's in the core of the diffusion model. But that implies like the core is the diffusion model and the text is basically is I wouldn't say it's a minor part, but it's clearly a part that's injected into the representation, right? Yeah. And so as you deal with multiple modalities, I can't imagine it's as simple as adding additional like attention hits, although that's what everyone, mostly people seem to do, right? And especially when you talk about like state action pair inputs in real-world actions, right? I'm not even sure if it should enter at the representation layer. It shouldn't, at least to me, it doesn't seem like it should enter the same way as a text embedding or a 3D point cloud or neural radiance field or whatever other information. Some information is information, and action is a different type of representation, right? In the way I as a human think. So I am curious as to what you think about how each of these modalities play a role in a more intelligent system, right? Let's not call it AGI because that's too ambitious, but let's call it a more interesting and more useful system. Which of these modalities are like the head? Which are the arms, to use an analogy, right? Which are the core of the model? Which are the parts that give input, and which are the parts that decide on action, right? Have you thought about that?
Yeah. The development of multimodality model is currently not clear. And let's first answer the last question. I've thought this question for a long time, and I think there are two kinds of maybe AGI or AI models. The first one is that it's an assistant for human. It means human asks the question, or we have some kind of need, and the AI just do it for us. And in this way, the language model is the core application is the core model, and then the computer vision model is with some kind of maybe just to capture the information. But there is also another maybe AGI or AI model that it works by itself, such as it's a robot, and it just maybe you wanted to buy something and it will just get away from us, and so in this way it has to capture everything by itself, and finally maybe he has a question asked human instead of in the reverse. So in this way, computer vision is much important than maybe language model. I think it's because maybe we don't need it to just say it. It can do it with computer vision, and for example, we can pick up something and do the action. As for the action part, there's no answers to how do we perform the action. Currently, most of the large models just predict the action sequence, and then we just recognize it with regex expression, and then we have step one, step two, and then just do it by coding. I don't think it's maybe the final version of action, but maybe we will we will need something like language for maybe tools or actions. It's kind of like XML or JSON, so that the AI can communicate with AI can communicate with the reality, and inside each line of the JSON or XML, it just know in this step I need to do maybe scene one, and the next step is scene two. It's a new kind of language between AI and the reality. Yeah, I thought it will be like that.
Great. And maybe one follow-on question for you, right? So my first question was about whether some of these modalities are more important, less important, more core and less core, right? And maybe my second follow-on question is, when you have so many modalities, right, some of them are probably going to be kind of entering at the same level. Again, the example is multiple attention hits. That's a common way for incorporating multiple modalities. Are you worried about possible balance or importance issues between these modalities, right? For example, we as a human, right, we receive inputs through our 5 senses, but sometimes our vision is more important, sometimes our hearing is more important, sometimes our taste is more important, right? And then I do wonder that once you start adding multiple modalities together, a classical problem in machine learning or AI is really, how do you know which one is actually important in the current context, right?
It's an interesting question. Currently, we just tried to merge large language model and the large computer vision models. In this way we can decide which is important. But in the future, when there are multiple maybe sensors, it's a hard question. Maybe we can live with the future.
Now that's kind of expected, right? When you only have 2 modalities, well, the assumption is both are important, right? Why else would you combine 2 if you didn't think they were both important? The question only arises when you have 3 or more modalities. That then clearly one's got to be less important than the other in most applications. But I think that's a good stimulating thought for the future as people think about how to, if one pathway to more capable AI models is to increase the number of modalities, then we will also have to think about what's the mechanism for deciding which modality is the most important in a given application. All right, so any other questions from our audience? One from on our online audience?
Yes, one from online from Mohammed Mosharraf Hossein. I'm just going to allow him to speak. Mohammed, we can hear you. Go ahead. Okay, are you muted? We don't hear you. Okay, go ahead, Mohammed. He's muted. Mohammed, you need to unmute. Maybe take another question in the meantime.
Okay, so we have a question.
Thank you for a nice talk, and it's amazing to see that we don't need to come to Beijing to experience the talk by Beijing Institute for Artificial Intelligence. Alex Javrankov, I'm the CEO of a company called Insilico Medicine. My question is that, so you've got Flex Studio, right, and many other tools that make AI more accessible to the audience. And we know that, the true key magic behind ChatGPT is the human reinforcement learning, basically, right? So I think that we realize that human contributors can polish the generative systems to the level where it becomes conversational and pleasant. In your Flag Studio, do you have any way to utilize human feedback in order to polish your models at this point in time? And also, if not, or if yes, do you capture the way they interact with the system in order to learn from humans?
I said in the talk, and we have built a system called Flag Studio. I think the aim to build this platform is just to collect some user feedback, and we collect you click like or unlike, and I click the results. Finally, we choose this like and unlike images to fine-tune our model, and this is on our schedule. We also developed the mobile version. That is just to easily we can reach these platforms. Yeah, we believe the IOHF is an important part of future AI, and we are also trying to do it.
So that's great that you are using it, so I'll just extend the question. So how long has Flux Studio been around?
I started maybe 2 years ago.
So
But sorry, 2 months ago.
And do you know, so how many human inputs did you already get for future training currently?
To be honest, we collect not many, not many feedbacks, and maybe there are only thousands of images which can be used for fine-tune.
Yeah, because the reason I'm asking this question, and for everybody in this room, so we are also exploring quite a bit human reinforcement part, right? And I think that we need to actually have more discussion on how to capture this. So it's ChatGPT level. Yeah,
it's quite hard to activate this, activate the human to give you the feedback, and we do not have the motivation to do this thing in most cases.
Yeah. Thank you.
Right, maybe let's try to get that. Philip, do you think we were able to get the question from the person online? Okay, not a problem. Then in that case, let's thank our speaker once more. Great, so that is the end of our program, which I hope you all have enjoyed the collection of talks ranging from very application and sustainability oriented to fundamental developments in the space of large generative models and other topics of interest. So with that, we have entered the closing phase of the workshop. I'm not going to call it a closing ceremony, but I would actually like to invite the any organizers and speakers in the audience to come up for a group photo, if we care. Okay? So, and I think, Philip, we have a token of appreciation for our speakers as well that we'd like to bring up. Okay, so speakers, organizers, would you kindly join me on the front? Keep it rolling so that we can make the photo taking part of the closing, and then we'll conclude the workshop. Okay, right. Okay. In fact, do not dissipate yet. At least let me identify who are the speakers in the audience. Philip, would you be so kind as to help me hand out the token of appreciation to, I guess we do have enough for everybody, right? Looking at the number of boxes.
Start at this end.
Okay, so coming here, so Hector, thank you very much. Token of our appreciation. Yong Hao, it's Yabin. Okay, Ilya. Okay, Victor. Willie. Muhammad. Daniel. Alex. And San Kaup. Right. Oh, I get one too. Wonderful. All right, thank you for handing it to me. Okay, so from here on out, that's the end of the workshop. So we have a social event coming up. So right now, what's the time right now, Philip?
It's somewhere between 3:30 and 3:40. There's a bus leaving at 4 o'clock.
Great. So from now until about, let's say, 3:50, is coffee break time. And then we have a social event, which is a tour of the Louvre Abu Dhabi Museum downtown, followed by a dinner at Fouquet's, which is a restaurant in the Louvre itself. So all speakers and organizers are welcome to join us for the museum and dinner. We also have a set of extra tickets in case anybody else in the audience, students included, wants to visit the museum downtown. Please feel free to come. We do not have enough places for the dinner, regrettably, but you can come for the museum trip. And the ticket is free of charge. Okay, so if you wish to join the museum tour, just be in this room at 3:50 p.m. and then we will walk everyone off to the buses.